Alright, so today we're going to look at 4.2. 4.2 is the mean value theorem. This is kind of the bread and butter of derivatives, where we're going to be looking at something that's going to be highly applicable and somewhat concept-based, but still pretty algebra-based, where we'll be able to solve for things and determine values. So there's a couple versions of the mean value theorem. We're going to look at two versions of it today, and then when we talk about integrals later on, we will come back to it for the integral version of the mean value theorem. So the first part of the mean value theorem I want to focus on today is called Rolle's theorem. It's kind of like something you get from the mean value theorem, and I'll go into exactly what the mean value theorem is in a second, but it's a result of the mean value theorem, but it's very useful, so I want to cover it first. So what Rolle's theorem says, which again is a very special version of the mean value theorem, is that if y is equal to f of x is continuous on the closed interval ab, and it's differentiable on the open interval ab, and f of a is equal to f of b, then there exists a point c in the interval a to b such that f prime of c equals 0. Let's break down that sentence for a minute. So let's talk about the rules of Rolle's theorem. First of all, f of x has to be continuous. That's number one. If f of x is not continuous, this theorem does not apply. Now you still might get a derivative that equals 0, however, you are not guaranteed. What the theorem does is it guarantees you that value. The second thing is that it must be on a closed interval a to b. So for Rolle's theorem to apply and the mean value theorem to work, you have to be on a closed interval. The next thing you have to have is you need to be differentiable on the open interval. That's how the mean value theorem works. Those are the conditions for the mean value theorem, and then this next part is special to Rolle's theorem, which is that f of a is equal to f of b, where a and b are not the same values. This means that the y values are the same at 2 points, where the x values are different. If you have all of those things, and once you have all those things, then we are guaranteed that there exists a point c, which is an x value, such that the derivative at that point is 0. So m is equal to 0. So let me show you what I'm talking about, and then I'll come back to this graph right here, but let me show you on another graph. So here I have a portion of a graph, and I have it on a closed interval from a to b. I think it's restricted from negative 1.27 to 1. And what that means is that I'm guaranteed to get a derivative that is 0. Now, as you can see, this graph goes down and then comes back up. Well, imagine it did something else. Imagine it went up and then back down. It still has to reach a point where the sign of the derivative changes. And we know that if the sign of the derivative changes, then there has to be a 0 derivative. So let's just check that out and see if we're right. Here's the slope of the derivative. So as you can see right here, the slope is negative, and right here the slope is positive. So if I just let this play back and forth, you can very clearly, oh, I lost it. Hang on, my computer's a little slow. Oh wow, it really took off. That's alright. You can very clearly see that at this point right here, the derivative has to be 0. So going back to this, here's just a curve where f of a is equal to f of b, and so we get that it goes up, and then look, the derivative has to be 0 here, and it goes down. That's one part of the mean value theorem. More generally, The mean value theorem says that if you have 2 points on a graph, A and B, then if you find the slope between those points, like this, then there exists a point on the graph C such that the derivative at that point is equal to the slope of this line. So you can see how that can be extracted to get Rolle's theorem because it's a very specific case. But the mean value theorem actually says that if you were to connect the endpoints of a graph, or any 2 points on a graph for that matter, then there is a point in between those such that the slope of the tangent line is the same. So right here I kind of wrote down, not in mathematical terms, but more in just common terms. The mean value theorem says that somewhere between x is equal to A and x is equal to B, there is at least, now there could be more than one, so there is at least one tangent. I'm going to highlight that. There is at least one tangent that is parallel to the chord AB. All we're saying here is that simply, if you were to find the slope between these 2 points, because of the mean value theorem, you can find an x value, so an value in between A and B, such that the derivative at a point is the same. So the slope of this tangent line is the same as the slope of this. And so if f of x is continuous on the interval a to b and differentiable on the interval a to b, where this one's closed and this one's open, then there's at least one point C in a to b where the derivative, so the instantaneous rate of change, the slope at that point is equal to the average rate of change.